In this module, we will see how to perform multiple regressions and to create the residual plots to assess the regression conditions for ordinary least squares. Once again, we use the measure to look out in Stata. In this case, we begin with a scatter plot of gross aggregate savings in 216 countries versus nominal GDP in those countries. And we can see from the scatter plot that while a simple linear model is appropriate, it fails to capture all the variations in gross savings. If we look at the regression results, we notice that the coefficient of X variable GDP is positive and is significant as expected. This basic model captures only 61% of the variations in the gross savings. The run at multiple regression is a simple matter of augmenting the simple regression command, and in this case we'll use the command window rather than the menus to perform a regression. So we click here at the command and we get the command window down here. We say regress as our command and identify Y variable, the response or dependent and the independent. To this model, I would like to add consumption and suggest in rather elementary way that savings is a function of measured income of GDP and consumption. Hit enter. We can't make a simple 2D scatter plot, but note positive coefficient highly significant on GDP, higher income, higher savings. Negative coefficient on consumption also significant. The more a country consumes, the less they save, other things and income being equal. R square is now 99.57% in this case. In any regression, we want to evaluate residuals, and this is cross-sectional data, and there are two evaluations that we want to do. The simplest is the check for almost codesticity and nonlinearity, and we do that by plotting the residuals, graphing them against the prediction value. We find them among regression diagnostic tools, and go to residuals versus fitted plot. No input requires, and we immediately follow the regression. Hit OK. And the result, what we are looking for, is the random scatter above and below the zero horizontal line. Another assumption in regression is that the residuals would be normally distributed. To examine the residuals, we first need to save them, and then we can graph them. This is the post estimation command, which would be defined under post estimation, prediction, residuals, etc. Let's create a variable name that we call as resid. And we go to standardized residuals and say OK. This will convert every country's residual value to a z-score, that is the deviation between the predicted and the actual divided by the standard error. We see that there is a great deal of missing data in this data set. We can now graph that residual variable. Notice that there's a new variable in the list of variables, and we are interested in whether the residuals are approximately normal. Easiest to do for that is normal probability plot. So now we would specify that we need the NPP of residuals. Simply hit OK. And in this particular regression, we find the market non-normality. So despite the outstanding R-square, the residuals actually indicate some problems with this regression, such that we might be reluctant to use it for estimation purposes. Imagine though that the model were appropriate for the estimation. We know that we could manually substitute a GDP value, a final consumption value, into the equation generated by the regression, and come up for the point T estimate for total savings. But alternative approach is that to have Stata perform that calculations for us to generate some intervallist events. So let's imagine we have a nation GDP of 90 billion and we estimate the consumption 75. So let's see what the model will predict. So back in post estimation, we want to compute marginal means. In this dialog, we first go to Add tab, and we need to specify the values for the predictor or the independent variables. So we click Create, and identify the fixed values of GDP as 90, then the consumption at 75. Hit OK. And then issue the command. The result is based on the ordinary least square model. At these particular values of covariance, estimated savings would be 13.5 billion, and a 95% of confidence interval of that value is given to the far right. This is 95% of confidence interval for the mean of the countries whose GDP and final consumption expenditures are 90 and 75 billion respectively.